right, so let's look at a model of exponential decay. The number of pica in a region is decreasing. How does the decrease in the pica population for years 1 to 5 compare to the population for years 6 to 10? So first, let's write an exponential model for this decay. We have, because it's a decay, let's see, f of x equals a times 1 minus r to the x power. So a is going to be the starting population, or the initial population they told us was 144. And they are decaying at a rate of 8% every year, so that's going to be 0.08 raised to the x power. All right, so f of x equals 144 times 1 minus 0.08 is 0.92 raised to the x power. So this is the model we're going to use to compare years 1 to 5 with years 6 to 10. So we are going to compare the average rate of change. You guys have heard that word before. Do you remember what average rate of change is? It was on your last test. We're going to find the slope. So let's take a look at first the average rate of change for years 1 to 5. What that means is 1 is going to be less than or equal to x, which is going to be less than or equal to 5. Remember, x represents our number of years. And this is an interval from 1 to 5, years 1 to 5. 1 is the least number of years, 5 is the greatest number of years. What we're going to do is we're going to find f of 1 and f of 5. So f of 1 is just taking our model up there, 144 times 0.92 to the first power, plug in a 1 for x, and we get back negative 9.25. So that gives us an ordered pair. We plugged in a 1 for the x, we got back a negative 9.25 for the y. So again, f of 1, we're just plugging a 1 in right there and using our model to get the y value. Well, now we need to find f of 5. That means we're going to plug in a 5 for x. 144 times 0.92 to the 5th power. When we do that, we get 95. And if you guys are checking on your calculator at all, you would see I made a mistake here. That's not negative 0.2925. That should be a 132. So sorry about that. Our second ordered pair, our x was a 5. We got back a 95. Average rate of change is to find the slope. So we're going to find y2 minus y1. So 95 minus 132 over x2 minus x1, 5 minus 1. So we do that subtraction, we get a negative 37 over 4. And then we divide that on our calculator and we got a negative 9.25. So what that negative 9.25 means is that for years 1 to 5, the pica population decreases, because it's negative, by an average of 9.25 picas per year. So we're just finding the average rate that is decreasing. So average rate of change is slope. Okay, so now we have to do the same thing, but this time we're going to find for years 6 to 10. So same idea, that means that 6 will be our smallest x all the way up to a 10. So we need to find f of 6 and f of 10. So f of 6, we just take a 6, we plug it in here, we do this math. So that would look like 144 times 0.92 to the 6th power. When we do that, we get 87. So there's an ordered pair. 6, 87. Then f of 10, we're going to take a 10 and plug it in for our x. So 144 times 0.92 to the 10th power. We get back a 62 when we do that. So that ordered pair is 10, 62. All right, average rate of change, we're going to find the slope. So y2 minus y1, 62 minus 87 over 10 minus 6. 62 minus 87 is negative 24 over 4, gives us a negative 6. So what does that negative 6 mean? That means that for years 6 to 10, the pica population decreases by an average of 6 picas per year. All right, so the question was, how does the decrease in the pica population for years 1 to 5 compare to the population for years 6 to 10? So here that is in one sentence summed up. The average rate of change for the pica population, so that negative 9.25, that negative 6, it decreases as the years increase.